Hi, my name is Adam Weissman. I'm a student at Flatiron's online self-paced software bootcamp, and this is Garrett Halstein. He's a graduate of Flatiron who now works at IBM and has a YouTube channel where he helps students, not just Flatiron students, anybody, learn about algorithms and data structures. One of the things that is most important to me, I when I ask somebody questions is to find out how do you not just like, oh, when do you wake up for breakfast and that type of stuff, but more of like how did you measure yourself so that you always knew that you were improving, that sort of that cycle to improve. I'm going to get the quote wrong, but in Gary Kasparov, the chess master, he wrote this book on chess, how life imitates chess. And he said that the question that the interviewers were always asking him wrong was essentially that they were asking him about things that didn't matter, and that the question that he wanted to answer, as he reflected as he got older, was essentially, how did he measure himself? How did he know that he was growing? And, and then also like, basically kind of like more reflective. So with that in mind, having watched many of your videos, I know that you worked at another company before you worked at IBM. You did that
Yeah.
for about what, like 9 months? Is that correct?
Oh, well, I finished Flatiron in like September 2019. In there, I applied for IBM. I applied for a ton of different companies, and then IBM's like interview process, it takes like forever, pretty much. Like basically from the day I applied to the day I got the offer, it was probably 3 months later. And in that time period, I accepted an offer for this like small contract role because I just wanted to start working. I just wanted to start building my experience. I didn't like being on the job search. It was stressful, and I'd rather just be working towards something. So I accepted this little contract role that didn't really have any it didn't really have any agreements. It was in New Jersey, so I didn't have to. That's a free will state. I didn't have to say, I have to be stuck here for however long this contract is. It was just like, you can work here, and if you want to leave, if you don't like it, you can leave. So like I worked there, and then I probably heard back from IBM in November saying we are want to move forward with you on the interview process or whatever. And then from there I just got the offer, and after that I just finished out my contract role until like the start date at IBM, and I moved to Poughkeepsie where I work at IBM now. So it was an interesting process, like and it, I don't know, for some reason, like I didn't have too much trouble getting, I'd say, like traction on my resume. Like I feel like recruiters were coming back to me. I got a few offers, but at the end of the day, I still thought the job search itself was really tough. It was just like, instead of like being in like the boot camp where you're just like, learning and doing work, it's just like, well, I feel like I should do that, but at the same time, I should also be applying to all these companies and like studying my next interview of like the person I'm going to talk to. So it
Right.
just feels like, oh, there's like, it's like endless. And that's kind of what made me, want to make videos. Cause I'm like, there's not even Flatiron has a lot of, career coaching and stuff like that. But even with that stuff, it just feels like, wow, you can really get lost in this stuff.
Yeah, it does feel that. Yeah, there's people always posting resources, and if you follow every, resource, you won't spend any time coding, or learn how to do anything.
Yeah.
So, when you started to tackle the data structures and the algorithms, I think a lot of people find it or are worried initially or scared off by the math, the idea about big O notation and all that.
Oh, yeah.
So what was your, I guess, like the point of entry into that world, and how did you, like, at what point did you stop being the beginner in data structures and algorithms? And then at what point would you say where you were an advanced beginner? Like there's still a lot of stuff that you didn't know, but
Yeah.
you essentially knew enough to be like, to get something out of the puzzles and those type of questions.
Yeah, I definitely understand what you're saying. Like, it's just like even now, like I'm teaching it, like making videos, like going over each individual problem. Really have to understand the data structure, and I find myself learning more every day just by doing that. So like, yeah, there's definitely like I feel like it's just the if you keep putting in the practice, it just and you keep like sleeping on it, like building your understanding of it, it just gradually you become a lot better at understanding it. And then it's just like in my case, I was lucky because right before I started Flatiron, I was in college and I was in my last semester, so I took a computer science class in college. And that class, it was the intro class, but it was the second part.
Right.
So instead of learning just how to program, like really basic stuff, I had to self-teach myself Java like a couple of weeks before I took it. And then from there, they were starting to introduce algorithms and data structures in the class. So from there, I was able to build a good foundation for understanding data structures. And that's why, like, when people start learning it, I definitely recommend, if you understand programming, if you can program, you build small little programs and use arrays, stuff like that, then you can start learning in depthly about data structures. You can take like say a Udemy course on say the language you want to use is JavaScript. You can find a JavaScript like data structure Udemy course, follow it through, and as you go through it, I'd say like practice algorithms related to that. And that's why I feel cracking the coding interview is like a really good source, because they have the chapters for a certain section broken up into the data structures. So like say you're learning about arrays, you can go through the array chapter, and as you learn about it, you can try to practice solving algorithms in it. And then it's almost like a positive feedback loop. The more you do it, the more you get out of it, and then you just keep doing it, and that I guess memory, that
So
practice build up.
so this is like a weird question. I hope it's not a stupid question, but when you say practice and understanding, right? What how do you define practice and how do you define understanding? Because just for context, for people that are, if somebody's watching this or whatever, sometimes when people hear practice, they think it just means repetition. But you can, somebody who's practicing guitar, let's say 10 hours a day, but if they're just playing the same single
Yeah.
chord, they won't get any better. They won't have any greater understanding. So is it sort of like what's the what does the cycle look like, so that when you understand something? Is it about being able to use it in a different circumstance? Is it that you recall it from
Yeah.
memory, or is it more like you see something that's similar and you say, oh, this is what the data structure is? Or how does that work?
That's a good question. It's like, it's definitely not just like, doing the same algorithm over and over again, like for sure. Like it's the fact of like, there's like small like steps, I guess, in solving an algorithm where you typically rely on like using knowledge from data structures and stuff. Um, and with that, as you like practice different algorithms related to like the same data structure, say you're like searching through something and you need to keep track of certain things in it, and you only want to do it once, and you might want to use a hash where you can store it and then quickly look it up after. And the idea of like doing that in different situations, like, oh, I need something to, like in this algorithm, oh, once again, I have to go in and store stuff and quickly look it up later. Like the doing it a few times on different algorithms, it starts making you say, okay, it's time to use a hash. Like this would work for me. And it doesn't just come like off like right away. Like it could take it could take like trying to solve like 10 different kind of algorithms related to that to really get it ingrained your thinking.
So this is a weird question for, I'm not familiar with too much with algorithms or data structures. But from what you're saying, is it fair to say that if you're learning this stuff, the way that you know that you're making progress is when you encounter an algorithm, you know which data structure to use? Is that, or am I
That's a
butchering the concept?
no, that's a good way of looking at it. Like if you at first like didn't understand like okay I what because at the end of the day like any algorithm you can probably just solve with an array. It won't be the most optimal algorithm. It won't be the most efficient one, but you can like solve anything with an array. And then if you know if you say you like go ahead and say you go ahead and like actually try running that algorithm say on LeetCode where they
Right.
actually give you like compared to like other people's solutions and they say oh well this performed like 98% in speed or this performed like 2% in speed. If you solved it only using your understanding of arrays and like didn't implement like a faster algorithm, a faster data structure for that
Right.
certain situation, you're going to see, okay, you're behind. But if you can start solving solutions on say LeetCode and you start creeping up in like the say speed ranking, like you start solving them at 2% and now you're solving them at like 50%, like obviously you're seeing progress there. And that's because you're learning to use the right data structure. You're learning to not only use the right data structure, but you're thinking more cleanly. You're thinking more optimally, I guess. And it's not all related on data structures, although it's strongly that's a big part of it. And if you don't really understand why you're using this data structure, it's probably one you might like need a brush up on that data structure, particularly like learning why you would want to use it. And two, like if that's hard to conceptualize, then maybe it's like big O notation, which I feel is like super important in understanding, why you care about speed, why you care about space complexity.
Right.
Because when you run an algorithm, what makes it go faster is if compared to other solutions is if its time complexity is down, right? If you have a lower time complexity, if you can solve the algorithm without having to say iterate through the entire array or only do iterate through it once, you obviously have a faster algorithm. But if you're if but if you don't understand like why you would want to use a certain data structure to say make that more efficient, it'd probably be in your best interest to like look into why that data structure is being used,
Right.
study it, and then HackerRank on YouTube
Right.
makes a lot of good data structure videos.
Right.
So like that's like a good resource. And like it's all about like just trying to improve. So like say even let's say you like try solving an algorithm and like let's say you find you got like 50% or of speed in LeetCode or whatever, and you want to improve on that. So you would look at the solution and then you would see, okay, this guy used a hash map for some reason. I don't know why, but he used a hash map. And if you're asking that question, then it's probably best to like go look into why they did that, right? So like
Right.
then you can like study why use a hash map, why is that better than just using an array. And um and that's kind of like the process of it is it's just about looking at how you went about solving it, and then if and see what, because they're in LeetCode they do have like the most optimal solutions usually pinned up there. So it would be best to like look at why they did that. And that's that's why I like really breaking down the process on like whenever I do the coding interview videos, because I want to like emphasize, okay, this is why we're using this data structure, or
Right.
this is why we're solving it this way, because it's a little more optimal than just say doing that. And I don't know, that's
No, no, that's
that's just
cool. That's really,
okay.
it's really no, it's really helpful because I think that sometimes it's like when you're doing code challenges, you can kind of get lost in, the why of it. And I think that
Yeah,
if you don't, also, I think if you don't really know the why, it's really hard to focus on the what or otherwise. So
Yeah.
another thing that I wonder about is, do you really make use of like in your daily job? I've heard that that the data structures and algorithms in general is something that's just for interviews, and then it's essentially never comes up again. Is that true, or to what extent?
Well, like I mean, you use them every once in a while. Like, I mean,
Right.
in writing like industry code, like obviously it's better to have the most optimal code, but at the same time, you're just trying to like make sure it's working and make sure like everything's like working fine. I mean, there's not like a data structure discussion going on at all at work.
Right.
Like no one's like saying, hey, like, so let's think about how we're gonna make this more optimal. It's more like, okay, let's get this working, and
Right.
then from there we can
So
maybe worry about optimizing it.
so
But
there's
like yeah, what were you saying?
no, I was gonna say, so there's not like a situation where like the boss calls you in and says, "Hey, explain like the time space complexity on this." Like that doesn't happen.
Nah, unless like a customer is like complaining, saying like, "Hey, like this is like taking really long to do or something," then you would worry about speed. And where I work in systems, when something comes up like that, it's just like, okay, let's just change the language we're using. Instead of using Java, let's use C++ because it's faster.
Oh
And then
wow.
that's what we actually do there. But I don't
Wait,
know how it is like other places.
so
But
if it, so that's sort of like, so like language like, let's say C++ or C sharp or any Java, any of those low level languages essentially will never go out of style for that reason, because basically the the higher levels of abstraction, the more stuff is getting lost in the
Well, yeah,
weeds.
like C plus plus, like I don't think it'll ever go out of style because one, like, video games are huge, and like and for that reason, like you want control over every little bit of things, and you want to take away that abstraction so you can like really control every like bit of memory that's happening, in your game and stuff. And to do that, you can't really use like the higher level languages because they'll just slow you down, and it just gives you less control. So yeah, like that's like why they tend to like stay in fashion because they work pretty fast, and like and for just writing like big applications, like it's just a more, I guess, they also have like a very like reliable code base, and they get updated regularly. So like that's a big reason to keep using them. A lot of developers, they don't like changing because when with change comes like having to like, okay, revamp this, and then once you update like whatever, say you move up from Java 7 to Java 8 or something, like obviously that's going to be like a lot of time and a lot of work you have to put in sometimes to like move around packages, stuff like that. So they like sticking with what they're used to, I guess. I don't know.
Cool.
So it's partly that, and partially just like a lot of developers are lazy, I feel.
Right
it's
on.
just it's just our mentality. Don't want feel like having to change everything around.
Right. Another, this is like, so this is like more of like a learning question about the data, about, because I think I have a good idea of what you were saying. Um, but I know you were chemistry major, and then you were planning to do pre-med and for a doctor, right, to become a doctor. And
Yeah.
there was another guy actually that from Flatiron who graduated the program in like 4 months, and he was a chemist, right? So I don't think I would have asked this otherwise, except for the fact that had that background in chemistry, and then you had the background in chemistry. Is there anything from that learning that you think that in some way has transferred over to the way that you approach this stuff? Because it just seems like a lot of people have like a really hard time. And I'm not saying that like to say you're making it look, you kind of do make it look easy. You know what but I know that that's not the case. So it's like, I feel, I'm just wondering, there must be something maybe from your
Yeah.
background and his background, that might be something in common. I'm just trying to, it's kind of an amorphous question. So
Yeah. Yeah. I mean, I would say like the one thing is it's like, the idea of like problem solving, like say organic chemistry, for example. I really like that class because, it involved like, a ton of like figuring things out, kind of similar to like code. Like you would work with these same reaction mechanisms and you try to get a final product. And it involved like, a lot of, not like memorizing, but like actually like taking like understandings of concepts and like applying them. So like being able to like certain problem implement the solutions for certain problems, um, based on like what your understanding is, or,
this is
or your base knowledge is. And I feel like that might help made it a little easier to just like jump into coding and then like saying, okay, like now I know how to code, like now I'm learning how to code, I can start applying these in certain ways. Um,
this is all right. So this is another follow up to that. And if I totally mischaracterize your approach, definitely correct me because I don't want any, to get the wrong idea. But like, if is it fair to say that your approach to problem solving is systematic? And when I say systematic, it's like, all right, so like a padlock with a dial, right?
yeah,
And you'll turn it or whatever. So imagine you have one padlock nested within another padlock. So you have these different dials, right? And ultimately, maybe there's like 5 layers and you have to unlock the thing, right? Are you essentially kind of, instead of like, some people will just twist everything and just see like, hope they get lucky, or they'll do something and then they'll read some crazy documentation. But is it fair to say that the way that you're approaching it is that you approach literally just like a single layer at a time, and then see how that one works with the next layer? And that's what I mean by sort of like kind of like a very methodical way. Because I guess when you're talking about chemistry, when you're trying stuff, and you know, and again, I don't really know about chemistry, so that's why I'm worried if I'm mischaracterizing. But it's like, if you're trying these different things, it's like it's almost like you're trying to cycle through to find the thing that fits, and then once you find the thing that fits, then you move on. Is that, or would you explain it a different way? I'm just trying to find an analogy.
no, I would. You're like onto like the right idea of it. It's like trying to break it down into like it's like most like simple like component. I guess like you don't want it like you have like the big picture, and then what you're trying to do is like look at like the smallest fractal, I guess, of like the entire picture, and see like if you can first solve that, and then like I guess like spread out and solve the rest of it. It's like it's trying to simplify it as much as possible, so then you can like I guess make like a more, yeah, as you mentioned, like a methodical like approach, instead of I guess like squirming. I don't like
Right,
just
yeah,
trying to
yeah, yeah, yeah.
like brute force it, like I guess.
Yeah.
And
So
like,
no, keep going, keep going.
oh no, like what were you saying?
No, I was gonna say, like, sometimes like say like like pry and Ruby, right? People will throw in a binding.pry, and I've seen times where people will just throw it in there, and then they'll test like 20 or 30 or like like just like half a dozen things, and they're basically just kind of randomly just seeing what's going on. And one of the things that I felt like was made a big difference for me is when I realized, I was like, well, you could just kind of flounder around, and I says, but if I have some idea of what I want to do and what I want to work, let me just try to pry the thing that will prove that idea, like that minimum, like the idea, like what you said about the fractal, where you get that
Yeah,
small slice. But how would you identify like what would be the smallest aspect of a
yeah.
problem?
like like it sometimes you can't, like sometimes, oh, maybe the smallest aspect is the entire problem, right? But like It's about like, I guess, taking like, all the fundamental knowledge and then just trying to apply it so that you can. Oh, sorry, that was really loud. Um, uh, yeah, take the fundamental knowledge and then from there just like, I guess, try to solve something with it. I don't know. Like like in my situation, um, like I would like, or actually how I was as a student. What I feel like in college, what really helped was when I would try to like when I was trying to learn things, I would hate memorizing. That was like the last thing I tried to do. And sometimes you need to memorize things. Like sometimes you just gotta like know something. But I would just try to like study like why it's doing things, like why this happens, and get all the reasoning there. So then when I actually have to apply logic, I would have the reasoning with me, and then like all I would have to do is be like, okay, now I'm applying what I know to something that I never heard of, and I'm figuring it out because it's doing that because of combining my knowledge, my fundamental understanding in this area, I guess. And like and that was something I was able to do a lot, I guess, in like my chemistry classes.
Right.
And it's just like, because of that, it may have just given me a little advantage into just like figuring things out. Like at least in my cohort, I was always like pretty big on like debugging things, because I would tend to just like, break it down and just say, okay, like why is this not working? And I would kind of systematically, as you said, go through it and like see, test all the reasons why it wouldn't work, and then I would usually like lead to a solution. And that was like probably like one of my good aspects in programming. I was like, that was what made me pretty good at least debugging stuff. And I mean, it's not really that related to learning data structures and algorithms. I feel when it comes to that stuff, it's more so just learn the concepts, the data structures, the big O notation behind it, and then as you practice like solving algorithms using that knowledge from them, you'll continually develop like a better understanding of it.
Right
But
on.
but as you mentioned, like trying to like complete labs and stuff like that, there are situations where you can get stuck at like a bug, and it'll just eat away at you. And sometimes, yeah, like sometimes I that oops, forget about that. Sometimes like I would have like a really big uh like bug that I just cannot figure out at all. But like a lot of times, like I would be able to just break it down into like and try to figure it out without just like ignoring, like, I guess, the facts that are there, just trying to use them to help me. And I don't know, that was like my approach of solving certain stuff.
Cool. No, this is really helpful. Is there because I know that you wanted to ask me a few things about for the Flatiron. Um and I guess so my last question is there any question uh that I didn't ask you that I should have? Like, is there anything that you felt like, we've talked about like a bunch of stuff, but is there
Yeah.
anything that we kind of danced around on you think that I should have asked, but I forgot?
um I don't know. I just like, I mean, we talked about a lot of good stuff, for sure, so that's good. I would say, and I like that we mentioned data structures and algorithms and trying to understand that stuff during the program. That's definitely good. But aside from that, I'd say like one of my biggest takeaways from the boot camp, one of the things I wish I did is, aside from like building all the projects there, it would have been really cool to maybe explore some tech, not spend too much time on it, but maybe explore a new technology that I didn't learn. And it would have been cool if I could have like done a little side project in that. I think that if someone wanted like a recommendation on something to do outside of Flatiron, that would have been like a cool project, because then you could put that into your portfolio, and it would kind of like uh, set you apart from, say, like, the cookie cutter portfolio or something. So you have any other kind of questions?
No, I mean, I guess like in terms of just in summary, start on data structures and algorithms now so that you're ready, for whenever you
The
graduate.
earlier the better. Like,
Right.
I've been preaching, like, more practice you put in, and if the earlier you start it, the more practice you get to put in and get to understand it. Because I mean, it's not something that just, what I don't like is that boot camps tend to leave that off, and then after you graduate, they're like, okay, you can pick this up. And it's just if you pick that up, like, as I said, like, you did like it 30 minutes, an hour a day, even during the boot camp, like, it would have been just so much easier to then go ahead and then finish off what you have to do during the job search, or you might already be ready for interviews by the time the job search comes. Because for me, when the job search came, and I wish I kept doing it, but I personally, like, stopped studying data structures and algorithms. I was like, I'm done. I did enough of this stuff, and for the most part, it worked out. But I think I would have been a little sharper at them if I kept them up.
Right. Right. Cool.
Some questions I got for you, just
Yeah.
being an online Flatiron student, like, my curiosity is just like how is like the curriculum different than because in the in-person one, we kind of like glanced over Sinatra. We didn't really like cover Sinatra much. I understand you guys have like basically a full module in it, and like for us, it was just like CLI mod, and then like you jump to you jump to learning Sinatra, like, for like maybe a week, and then you jump into like Rails, and then you build your project in Rails, fully in Rails, and then you do vanilla JavaScript, and build the project in vanilla JS and Rails, and then you move on to React, and then you do your capstone. So like I was just curious, like, is there any like differences between what I did and like how it was for you?
So the current thing is, so you do the CLI, you have like a CLI project that you do. Then after that, then you do Sinatra. It's like a huge module. It's huge. It was bigger than bigger than Rails.
That's super
And
interesting.
yeah, I guess it's like so that you can kind of like learn to appreciate Rails. Um,
Yeah.
you build a Sinatra project, full CRUD Sinatra thing. Then after that, then you do Rails full CRUD
Hmm.
project. Um, that's the one I just finished. Then you do JavaScript, a single page application with a Rails API that you use for the backend. And then you'll do your React, Redux, and then you do your capstone project.
All right. Okay. And like, I guess, like, what's like something you wish you known, like, you know like, or you wish you did, like, before the boot camp, I guess, like something that you can think of that you're like, oh, maybe if I prepared in that, or maybe if I knew this, like, coming in, like, I would have benefited from it.
Probably wish that I had started. I wish I had probably gone through like maybe some Udemy, like Ruby on Rails tutorial, like maybe done like 4 or 5 of them.
All
Um,
right.
only because I feel that uh, forward looking, I was mentioning a little bit of this in the pre-chat, but I I don't think I'm gonna have a lot of prospects that are necessarily related to Ruby or Rails. Like one of my friends who was a Rails developer, now he said everything's Node and React now, or and then like my brother was a JavaScript developer, now he's a Python developer, and he says, yeah, you're gonna have to know JavaScript and Python. So it's kind of like I spent like a month on my Sinatra project. um, the CLI project went by pretty quickly. I spent a month on the Rails project, and don't get me wrong, I'm happy with the projects, but when I think about how to like, time, it's not something that you can get back. I wish that I had probably that I had come in knowing a lot of Ruby to begin with, so that I could have sort of burned through that stuff, then double down on the JavaScript, have some time to learn Node.js, have some time to like do some Python stuff, mess around with data structures and all that other stuff.
Yeah.
So that it's not like I finished the course and then it's like you have 90 days to choose say, hey, I'm starting my job search. It's almost like, it would be nicer to be like, in the amount of time that you have to do the self-paced, to use it as the time to experiment and to do things that are unusual or really stretch you. Because I feel like that once you get into the workforce, the time to experiment, it goes down by a lot. And not just that, but that even the motivation to learn, like if you're on a salary, and I mean, like, this probably sounds really lazy, so hopefully employers will listen to this part, but it's like, it's like once you have the job, the incentive to learn like a new stack goes down, unless it's something that you're going to be like, you have to do for work, or it's a job that you're applying.
Yeah, I completely get what you're saying. And like, actually, when I started, working, I was like, okay, I'm taking a break. I'm done. If you look at my GitHub, like probably the day I started working is when it pretty much went from all green to like nothing. Like,
Right.
I just like, took a break until like recently I started doing a little stuff. And actually now, like, I kind of rekindled some kind of desire to start like picking up like a new stack. Like I was like, I would love to like, learn more artificial intelligence and stuff like that. So that's something I'm kind of like doing on my own. And thankfully IBM has like, some kind of like their own kind of courses that I can like take and,
That's awesome.
like learn a lot of stuff from. So that was really cool. And it's nice they kind of like motivate us to do it. They're like, get 40 hours of learning a year, and that's like a requirement. So that's cool. And I feel like that kind of helped me like say, okay, I'm gonna start bettering myself. I'm not just gonna be working my job. I'm gonna also try to be learning outside of it. And they also have like this thing called like the Jumpstart program. And that also like it's supposed to promote us like working basically like on like a hackathon type of thing with other IBMers who just started to like build like projects and kind of work outside of what you typically do. So that's like I feel like that's really nice, like coming into a company and like being able to like they basically telling you like, we want you to better yourself, not just do what you do here, but also like better yourself on the side. And I feel like, that might be like a goal for you to like shoot towards like a company that promotes that, because it's hard to like, I know what you're saying. Like after my contract role, like I was definitely motivated to learn Golang because that's what I had to learn, and I had no idea what it did. But aside from that, I was just like, I don't feel like learning anything. I was pretty tired from learning Golang on the side because that's what I had to do.
Right. Do you what is your and this is like, do you have any what's your like 5-year goal? Like where do you want to be, like 5 years from now? Like, do you want to be still back-end software, or you mentioned AI and machine learning? Do you want to be, machine learning developer, something like that, or is like, what's the future?
I mean, honestly, it's hard to say because like, there's so much stuff out there. It's really like hard to pick. But I definitely, learning machine learning now to like, see if that's something I want to like keep pursuing in the future. And my goal right now is actually I was considering this program for Georgia Tech has like this online master's program that's like super cheap. It's actually ridiculously cheap. It's like, I think probably like $7,000 or so for like a total for like to get your master's. Like, wow, that is like the last thing you would expect from a school coming up with an online master's program. But like it's super cheap, and I figured like I would try that and like kind of explore like different aspects of computer science and see what I really like, because it has like a machine learning track, and it has like a, you know, a typical like systems, like software developer check. And then it has like, I don't know, interactive intelligence, and then like robotics. So I figured I'd try that out, and like learn about all those different kind of things, and then from there I can make like a good decision. Okay, and like maybe in 2 years if I finish it, like, okay, I want to go down this route and, you know, become that kind of developer. But as of right now, I'm pretty open to, like, you know, how it's going to end up being. I like what I'm doing now, but I would also love to like see what else you know, technologies are out there, because, you know, I just a year ago I didn't know anything. So like I feel like there's so much more to really discover and learn.
Right. Cool. Are there any side projects that you're working on, or anything that you'd be excited to work on?
Um, my friends were like, we're always talking about, like, from Flatiron, like from our cohort, we're always talking about like, oh, we should like open up some kind of like e-commerce site, or something that we should like start building, and like I really want to get on that with them. So I as of right now I'm not working on any side projects. If you want to call the whole YouTube thing just like, you know, helping other, like, you know,
Right.
boot camp students, you know, get to where they want to be, like that's kind of all I'm doing right now. But I actually, like, a goal of mine as well is like, you know, it as if like, you know, people actually start liking my content and stuff on YouTube. I would really love to like put something out there relate that's almost like a boot camp itself on YouTube, where people can just like go to for like learning how to code and stuff like that. That would be really cool.
Would be
Um,
really cool. Yeah.
yeah, but that's obviously like super long term, and if people actually, you know, like coming back to see my videos and stuff. But, you know, for now I'm just like helping with like interview prep, and just giving as much resources as I can for like, you know, current boot camp students or like self-taught programmers. But like, yeah, that would be cool to like make, I don't know, some kind of like full stack development course on YouTube that anyone could like, you know, check out and learn from.
Cool. All right. Awesome.
Yeah,
um,
I mean, it was really awesome talking to you, Adam. Like, you know, this is good, and I mean, as you can see, like, you know, it's great that like we can like, you know, talk about this. You know, you're a current Flatiron student, and I'm like a Flatiron grad, and we can just like meet up. Like, I don't know how it feels like online, you know, since you don't get to see people in person and stuff. But I feel like the Flatiron community, like, you know, all your
it's great.
cohort mates and stuff, it's like a really good relationship and really good, you know, community to have. So
Yeah, that's what I think. That's probably one of my favorite thing is the community, the instructors, the students. You know, just even the staff, the support staff, everybody that I've dealt with
yeah,
at Flatiron's been really great.
everyone's awesome there. So it's nice to like, you know, I love like on LinkedIn, like reaching out to, you know, current Flatiron students, like just chatting about how it's going and how they liking it and stuff like that. It's good.
Cool. All right, awesome.